Our next speaker is Professor Valsamma Eapen. Valsamma is the Autism CRC Program 1 Director, which means she oversees all of the research and operations for our diagnosis and early years program. In addition to being a child psychiatrist, Valsa is an absolute stalwart of the Autism CRC and one of the CRC's greatest assets. In addition to her role with the CRC, Valsa is the Chair of Infant, Child and Adolescent Psychiatry at the University of New South Wales, UNSW, and is also head of the Academic Unit of Child Psychiatry at the South West Sydney Local Health District. Now, today, Valsa will be talking about how we can use neuroimaging techniques to better understand brain development in kids on the spectrum and how that knowledge can improve outcomes for kids. Without further ado, here's Valsa.
Thank you very much, Andrew, for the introductions, and thank you everyone for joining during the holiday season. So very quickly moving on to the next talk, if you like, on how we have used functional near-infrared spectroscopy, a type of imaging of the brain, as a tool to understand subgroups. And we all know that the biology of autism, or the way the brain is wired, might be in such a way that children are not interested in socially rewarding interactions, or in playing with other people, or interacting with other people. So usually what happens when your biology or your brain wiring is such that you are not interested in these things, children normally would get left out of the social milieu or the social loop. Children usually learn by imitation, by mimicking most of the things in the very early life before we even start teaching them anything. So being part of that social loop, social milieu, and observational learning is mostly how learning happens in early years. But because autism and the brain is wired in a particular way that you are less interested in that, you get more and more drifting out of the social milieu of learning, or the social loop of learning, which in turn cascades into them not being able to develop those skills which you so dearly need and want. And we know from the science of early childhood and brain development that initially when you're born, you have got very little connections for the brain networks. But the synapses start to develop, the axons start to branch with the dendrites, they form connections, and by the time you are in the second, third year of life, it's so densely connected. And from 4 years onwards, we are actually pruning them away. Things that you don't need, only the things that you really need and you use will be retained, and the rest just gets pruned out. So it is so very important to utilize that plasticity of the brain to make those connections during that first 3 years of life, for us to be able to get in and make a difference, or make as much of a potential in terms of wiring and networking and the connectivity to be forming within the brain in those years. So understanding the unique profile of each child becomes extremely important in giving the right intervention, if you like. So we believe that using neuroimaging techniques like the one I'm going to talk about a bit more is near infrared spectroscopy. People also use the magnetic resonance imaging, which is more of a structural part of the aspects of the brain imaging. Then we can also use eye tracking, EEG, evoked response potential, etc. And there are a number of studies that have looked at neurocognitive aspects of children with autism, and what we find is, for example, with the evoked response potential, normally a particular component of the ERP called N170 is larger when you are seeing faces, and it's prominent over the right hemisphere. But in those with autism spectrum type features, what we find is larger for non-face. Like that becomes more prominent when you are seeing a furniture or something of an object toy that's of interest to them than a familiar face. And if you look at fMRI, that's functional magnetic resonance imaging activation, when you show cartoon figures, amygdala and the fusiform face area, activation is the same in young children with autism and in typically developing children. But when you show them a familiar face, that differentiation, you can see that the fusiform face area is not activated in the way that you would like it to when you are watching or seeing a familiar face on the screen. So the whole idea of this project was to see whether we can see whether the children are more social brain oriented or object brain oriented. What was the level of social brain activity or flickering in the brain that was available to them so that we can target the intervention accordingly. So you're seeing that you can compare the relationship between the behavioral assessments and what we are seeing in terms of the brain activity when you show them a social stimulus. This is a video clip where a lady is singing "Wheels on the Bus Go Round and Round" nursery rhyme with a lot of facial emotions and a lot of gesturing and everything. And the other non-social or object-oriented stimuli is a spinning toy. So what we want to know is that what part of the brain is getting activated when children are watching these videos. And this is how we did it. The difference between an MRI scanner and a functional near-infrared spectroscopy is that all you have is something like a swimming cap on your head with some electrodes stuck onto it. It's portable. It is easy to set up. You don't need to go into big MRI machines, but we can get to see what the dehemodynamic activity of the brain is like. So here you're seeing that red activation of the frontal areas, and the red means it's more activity, and then the temporal frontal area. So social versus toy, we can see what area of the brain is being activated when children are watching this on the screen. And that's the temporal parietal area lighting up, and they're seeing the object toys. So this is how it would look like. The child sits in front of a screen with the cap on, and they are seeing the video being played, which is of the nursery rhyme being sung or the object toy. And we then can have a better understanding of how much of social brain activity is available to the child based on how the parts of the brain that activated when they were watching that social stimuli of the nursery rhyme lady. And what we found here is that normally you would expect a lot of frontal front part anterior activity, but you're not seeing much of a red at all when you are seeing that social lady singing. But when you see the object toy, you see that the posterior part, the visual part, is activated here. And here is a comparison in terms of what we see during fMRI. The red spot that's circled signaling you are perceiving the face. That's a fusiform face area, showing the activity that yes, you are perceiving that face. And the blue is activation of the non-face objects. What you see in control subjects is both the red and the blue actives, that is, you're perceiving both the face correctly using the fusiform face area, and you are correctly perceiving the non-face as well. But in the autism child, with the one on the right, the child with the features of autism, you are seeing that there is no red signal at all. The fusiform face area is totally not activated. So what we see as social brain versus object-oriented brain, there is a lot of gradations of that. So if somebody has got reasonably well social affect scores on an ADOS, and if we find that they have got good activation on the fMRI and the NIRS when they are watching that social stimuli being played, you can be pretty confident that the intervention using social sensory routines and motivating them through that area of the brain is a good possibility. But if you are very object oriented and the only parts of the brain that are coming alive is that object oriented parts of the brain, then probably your intervention should be more modeling that type of learning teaching paradigms. So we ended up with 3 subgroups based on morphological understanding. One was larger brain of the frontal lobe area, smaller brain in the temporal parietal. And clinically, they had higher nonverbal but lower social skills. Then the group 2 had smaller brain regions across the board. They had lower nonverbal and lower social scores. And group 3 had larger brain regions in general, and they had higher nonverbal and higher social scores. So again, the idea of the subtyping program is to understand what unique profile each child has, and also other children who have that similar profile. Can we group them together so that we can provide the right intervention, the right supports, and that can also come into play in the transition to school support as well. So again, having that better understanding and a deeper understanding of how your brain is activated, how your behavioral profile and your cognitive level and everything else that the family and the support and the environment is providing to you can be all optimized. And we all know that biology is just the starting point. Biology is not destiny. It's really the learning opportunities through the synapse dependent activity formation and those parts of the brain being activated time and again through interactions, through intervention, through matching, through modeling, and repetitively doing that, that we make those connections to come alive. And so everyday activities that children engage in across their day are building a more social communicative brain or a more object-oriented brain. And those who are less interested in the social aspects of life, how can we optimize during that very early first 3 years of life for the brain to connect in a way that would make it more a social brain, communicative brain as they move forward from then onwards, because that plasticity is so much available to you. So that's probably how we should be supporting each and every individual who has got symptoms, signs of autism. Understanding the heterogeneity is very much part of that and the critical step in tailoring the interventions. And definitely, it is not just about explaining to the families, but also we can provide the right supports, utilizing their strengths, what they are good at, what will motivate them. That should be our main thing that we foster when we are looking at transition to school. So they all have the right to optimum management, and better understanding will clearly help us to provide the right supports for the right child in the right setting at the right time, hopefully early enough. Thank you.
Absolutely fantastic. Thank you so much, Valsa, and also thank you again to Felicity for sharing their research, but also their experience. I certainly got a lot out of that, and I'm sure others did as well.